Hello, Curran here. This video is about making line charts and area charts with D3 and SVG. If you want to learn about visualizing data with a line chart with a single line, and you've followed along with the previous videos where we've created a bar chart, customized the axes, and created a scatter plot, then this video is for you. I'm going to start by forking this previous example, the cars scatter plot, by clicking fork right here. Then I'll change the title to be Temperature in San Francisco Scatter Plot. The data we're going to visualize here is a sample of 1 week of temperature in San Francisco. This is what the table looks like. We've got a timestamp and the temperature in Celsius. The timestamps go down to the hour. See, these are all different hours of the day. And this is 1 week's worth of data. So we'll see the temperature go up and down. This data was sampled from the Data Canvas Sense Your City project, I think back in 2015. Before we begin using this data set, we're going to have to upload it. So I'm going to click on Upload Dataset, and then I'm going to upload this file that I have on my machine. Week temperature San Francisco.csv. I'll set the name to be Temperature in San Francisco. Source name is Data Canvas, Sense Your City. And I'm going to copy this link and paste it here as the source URL, and then upload this. Next, I'm going to copy this URL here, and in our code, I'm going to use that instead of what we had before, which was the cars URL. So I'm just going to delete that cars dataset URL and paste this new one instead. Got some extra quotes there. Now all this stuff about parsing the data is invalid, but let's take a look at the data to see how we do need to parse it. I'll say console.log data. Then I'll open the terminal and see what we've got. Oh wow, look at that. We're importing format but not using it. I'm just going to fix that real quick. If we don't need format, let's not import it. But anyway, here's what our data looks like. We can unpack it and say, all right, we've got timestamp and temperature. So let's modify our parsing code to use this new information. We can delete all of this stuff, and then instead of parsing MPG, let's parse temperature into a number. And we've also got this timestamp, which really we should parse into a date object. So just to test out the parsing, I'm going to copy this string. And then right here in this console, I'm going to just check if we can call new date, the native JavaScript date constructor, and pass in this string. Will that work? All right, I think that does work. Yeah, this is a standard date format that we can just pass into the date constructor. So what we want to do is take the timestamp and set that to be a new date based on the timestamp string. So here I'm going to change temperature to timestamp and then change it there too. And instead of unary plus, we can say new date and pass in our timestamp string. Now if we take a look at our data array, we can see that these objects here have timestamp as a date. It's interpreted, parsed as a JavaScript date object. All right, now that we've got that sorted out, let me just clean up this a little bit. We don't need that white space, and we don't need this console.log. Now let's update our render function to visualize this data instead of the cars data. What I'm imagining here is that X will be time and Y will be temperature. So let's just change the labels. Horsepower is, instead of this, it will be time, and then Y will be temperature. Our X value should return d.timestamp, and our Y value should return d.temperature. All right, this basically shows the right layout of the points. Because we're using a linear scale for time, it's not quite giving us the right format here for these labels. I think it's using the number of milliseconds since 1970 or something like that. But if we have dates, we can use a different kind of scale called scale time. So for our X scale, I'm going to change scale linear to scale time, and also import that from D3. Now we have these nice date ticks, you know, the days that each of these lines represent. And notice how the lower temperatures are at the top and the higher temperatures are at the bottom. I think I'd like to reverse this. We can do this by changing the range of the Y scale. So instead of from 0 to inner height, it can go from inner height to 0. This is because Y starts at 0 at the top, and as Y increases, things move down the screen. So if the domain is the extent of the temperature and the range is from inner height to 0, that means that the lowest of the temperatures maps to inner height, which appears at the bottom, and the highest of the temperatures maps to 0 in pixel coordinates of Y, which is at the top. Just for fun, I think I'll tweak the colors here. What if we set the fill to orange and use the full opacity? I don't know, I kind of do like steel blue. Yeah, that looks decent. And I kind of just feel like making the circles smaller. So let's try changing the circle radius to maybe 6. That looks pretty cool. All right, so we've parsed this new data and visualized it as a scatter plot using a new kind of scale, the time scale. But this is not a line chart yet. But it goes to show that, scatter plots are pretty versatile. Next, let's go about converting this into a proper line chart. Oh, I'm just noticing I didn't update the title and the README. So let me just take care of that first. Let's make the title A Week in San Francisco. And I'll change the README to say, this scatter plot shows 1 week of temperature in degrees Celsius in San Francisco. The data comes from Data Canvas Sense Your City. And I'll paste that URL. I'm going to fork this to make a line chart, but first I just want to tweak the placement of this here. This is the Y-axis label, and I can tweak this number right here. All right, that looks good. Then I'll just adjust the left margin. Okay, there we have it. Now, let's convert this to a line chart. I'm going to keep this because it's kind of cool. So I'm going to fork this, and I'll change the title to say line chart. And I'll also update the README because I'll forget later, this line chart. Okay, now in the code, we're ready to change the circles into one line. So this is the piece of code here that makes the circles that we're going to change. For a line chart that has a single line, we don't actually need a data join because the line is just represented by one path. So instead of using a data join, we can just say g.append path. In order to make this path into a line, we can set the D attribute to be, well, what do we want this to be? We want this to be a line that sort of outlines where these points are here. So we need to use another part of D3 called D3 line. So before we even append that path, I'm going to say const line generator equals line, and line we need to import from D3. So I'm going to go to the top and import line here from D3. And this is where I always need to consult the documentation for D3 line. It's defined in the D3 shape package. So yeah, if you scroll down, I think the first thing you see is a usage of d3.line. And this is how we need to use it. We say line and say what the x and y functions are. So back in our code, here we're defining our line generator, so we can say line.x, and we already have an accessor function for x, and it's called x value. So we can say .x, x value, and then we can say .y, y value. And this should give us a proper line generator that we can use. Now, to compute the value for d, for the d attribute of our path, we can invoke line generator and pass in our data. This should work. I'm not really sure what's going on here. Maybe we just need to set the stroke so that it shows up as something. Let's try that. .attr stroke of, let's say, black. No, that's not it. So what I would do here is log this value and see what it is. Console.log line generator of data. And what is that? Is it working? Huh, it does seem to be working. See that? This does look like an SVG path string. So what could be going on here? Oh, I think I get it. These functions should return pixel coordinates, not the data coordinates. So yeah, silly me. You know, it should actually be these functions here. It takes as input d, and it returns the y value passed through the y scale. So that's what we can use for y, and we can use this function here for x. Okay, now it's working. Alright, so now we can go about tweaking the style of this. And I prefer doing this in CSS. So why don't we give this path a class of, let's say, line-path. To apply some styles to this path, we can copy this and then go over to our styles.css. And here we can select that class by saying dot that class, line path. And then here is where we want to turn off the fill. I mean, what we're seeing here is the fill. All that we want for a line chart is stroke. So we can say fill is none. That's a special value. And then stroke, this stroke can be steel blue. All right, now we're getting a 1 pixel wide line. And we can make it a little wider by setting stroke dash width to be, say, 5. And I think it assumes units of pixels. And I think I'll just change the color to be maroon. Now that we have the line, I think we can get rid of the circles. Although sometimes it's cool to keep the circles. I mean, it shows you where the actual data points are. But in this case, I think we can safely remove our circles. So I'm just going to select this code here and delete it. I'm also going to delete this console.log. We don't need that. This is pretty cool, but look at how jagged these line joins are. We can address this jaggedness. I mean, I would like to make it smooth. So we can do that by using a thing called stroke line join. And I think we can do that in CSS by saying stroke dash line join is, and this is where, again, I always need to look it up. But if you just Google stroke line join and come to this MDN page, you've got this nice example of the different options. So this is the one that we want, where it's nice and round and smooth. And let's see what value that is. Looks like round. Back in our code, we can say stroke line join is round. All right, now it's not nearly as jagged as it was. But that tweak really just affects the places where the lines come together. It's still a bunch of straight lines joined together. If we want to make it smooth in a different way, like using basis curves, then we can also do that by configuring the line generator. So here's our line generator. And there's another option we can pass into line generator, which is curve. And a commonly used one here is curve basis. And curve basis, we need to import that from D3. So up at the top, I'll import that. Now, instead of a bunch of straight lines joined together, it's actually a basis spline curve. This is how the documentation looks for curve basis in the D3 shape passage. It says, okay, this produces a cubic basis spline using the specified control points. So this is sort of what the kind of smoothing that it does. And there are many other options for curves. All right, we've made a line chart with D3 and SVG. Now let's make an area chart. To begin with our area chart, I'm going to fork this one because I'd like to keep this line chart as is. And technically, it's very simple to change a line chart to an area chart because we can just change line to area. So instead of importing line, we can import area from D3. Now our code is in a broken state. But if we go back down to our line generator, instead of calling line, we can call area. And we can rename this to be area generator. And then replace line generator with area generator. And you can't see it now because the fill is set to none. But if we go back to our CSS and we set the fill to be maroon, and now we don't need the stroke at all. Why isn't this showing up? It should be showing up. I think this should work, but I think now it's time to consult the documentation. In the D3 shape package, let's see the documentation for areas. All right, so area.x, area.x0. All right, so what makes areas different from lines is that instead of just x and y, they have x, x0, and x1, and also y, y0, and y1. So what we need to do here is, because we want it to vary in y, the area should go over the y direction, we need to specify y0 and y1 instead of just y. Back in our code, we can specify that, okay, dot y0, this should be, I believe, just inner height, because we want it to be sort of sitting at the bottom. So we can type inner height, and then y1 should be this function here. All right. Sweet, we have made an area chart. But one thing I don't quite like is how it ends at a different place than this grid ends. And I think this is because we're calling .nice on the X scale domain. So let me just try changing the X scale so that we're not nicing it anymore. If I delete that, okay, it goes up to the edge, but now we have too many ticks and these labels are overlapping. So what we can do here is customize the number of ticks that we're getting on our axis by, in the x-axis, saying .ticks and passing in a smaller number. I think the default is 10, so it tries to give you approximately 10. It could be more or less, but in our case we want less. So I'm going to say like 6. How about that? All right, that looks pretty good, pretty decent. All right, we've made an area chart, but you know, this doesn't really sit well with me because the area under the curve isn't really meaningful, to be honest. I mean, the baseline is set at what, 14 degrees? That's sort of totally arbitrary. And to me, the difference between a line chart and an area chart is kind of like the difference between a scatter plot and a bar chart, where with scatter plots, the domain, you know, it makes sense to keep it as the extent of the data because there's no concept of a baseline. But with a bar chart, in order for the area of the bars to make sense and actually to correspond with the values from the data, you must use a zero baseline, meaning the domain must start at 0 and then go to the max value from the data. And so with line charts, it makes sense to use the extent from the data because there's like no baseline. But with area charts, there really is this concept of a baseline because you know, what you're seeing visually is the area under the curve. So with temperature, it doesn't really make sense because it's not an absolute quantity. It's sort of all relative. So what I'd like to do is next is change the data to show the population of the Earth. That way, the area under the curve really means something. And for that, we can use a zero baseline. And it'll make more sense than temperature as an area chart. I would like to keep this here, so I'm going to fork this before changing the data. Then I'll change the title of this one to World Population Area Chart. I'm going to upload a new data set. I'm going to choose this CSV file that I have already, which is World Population by Year.csv. And I'll just tweak the title to have spaces. And this only goes up to 2015. So I'm going to put that in the permalink because probably there's going to be updated data in the future. This data comes from United Nations World Population Prospects 2017. And I'm going to copy the URL, paste it here, and then upload this data set. Then I'll copy this URL, and in our code here, we can use that URL instead of the temperature dataset URL. Again, let's take a look at what we've got. We can say console.log data, then open the developer tools and see we get this array of numbers where we have year and population. In our data parsing logic, instead of temperature, we can say population. And I believe this is population in thousands of people, so we can multiply this by 1,000 to get the actual count, the actual number of people. And for parsing year, I'm not sure if we can pass the year into the date constructor. Let me try that. New date. And if we just pass a string like 1990, what does that give us? Oh, it does work. See that? January 1st, 1990. So we can say d.year is a new date of d.year. And let's see if that worked. Yeah, that looks fine. It looks like it parsed the years correctly. All right, now that we've got that out of the way, we can remove this console.log. And remember, we've got population and year. And then we can change how the data is being rendered by updating the X and Y value accessors. The Y value should be population, and the X value should be year. All right, we've got something, but see how it's using the extent of the population? We want it to use 0 as the baseline. So to do that, we need to update our Y scale. Specifically, the domain should not be the extent of the data, but rather it should go from 0 to the max of the data. And now this is an array of 2 numbers. And I don't think we're importing max. So I'm going to scroll back up and import max from D3. Okay, now we're seeing an accurate area chart. This is really showing how, okay, this was the population in 1950, and this is the population in 2015. See, it more than doubled just in the last, what is it, 60, 70 years? That's insane. I don't know why we're not getting the 1950 label here. I kind of would like to see that. What if we bring back nice on the X scale? Okay, now we're seeing 1950. It looks a little awkward over here, but I think we can live with that. Now our biggest problem is the formatting of these numbers here. And I remember we dealt with this exact format with the bar chart. So I'm going to go back and find that bar chart example. It was the one about customizing axes. Yeah, we want to use the same format that we're using here for population. So I'm just going to sort of copy that out of here. This is it here, x-axis tick format. Back in our area chart, I'm going to say, all right, where we use the axis bottom, I'm going to paste that right before that. And actually, in this case, it should be the y-axis tick format. And I think we're getting an error because we have not imported format from D3. So I'm going to do that real quick. Import format from D3. And then I'm going to move this to be closer to our y-axis code. Yeah, right above our y-axis code. And then for our y-axis, we can say .tick format and pass in y-axis tick format. It looks like we're getting up into the trillions, which I know for a fact is not accurate. Maybe I was wrong about this number being in thousands of people. If I don't multiply it, it's a billion? Yeah, I think this is correct. Yeah, I think we're up at around, 8 billion people. I would prefer not to see these 0 zeros, and I believe we've done this in our, here it is, in our custom format. We've used 3 significant digits, and if we just use 1 significant digit, there we go. That's how it should look. 0.1s to use 1 significant digit. Now all we need to do is update the titles and the axis labels. So I'm going to update the title to be world population. The x-axis label still makes sense. That is time still. But we need to change temperature to population. And it's a little frustrating that this is positioned to the left all the time. I think I just want it to be centered automatically all the time. So why don't I just change the CSS for that one? For the title, I think it's text-align. If I'm not mistaken, can be middle. No, that's not it. Although I know we used the same thing for our axis labels. So I'm just going to take a look at the code and see what we did there. Oh yeah, it's text anchor. That's what it is. Text anchor should be middle. So in the CSS, let's use text anchor to be middle. Okay, so it's in the middle with respect to this point over here, but we want to make it with respect to the middle of the screen. So back in this JavaScript, we can position the title, and that's this right here. I'd like it to be in the middle of the overall shape. And I'm noticing it's getting appended to G rather than SVG, but I wanted it outside. So let's append it to SVG, and we can set the X attribute, .attrx, and we can set that to be the middle, which is width divided by 2. It's there, there's something there, but we're moving it up where we should be moving it down, I think. So let's just tweak this Y until we can see it. Okay, that's pretty good. That's pretty good. One thing I'm noticing though is that these lines, they go behind the area, but ideally they would be above the area so that you could still use them. It's a subjective point, but I would like to just make that change. The way that we can do that is instead of setting up the area after the axes, we can just move this code to be executed before the axes get created. So I'll just paste it up here. Now those lines are in front, so we can still use them. But honestly, I just don't like how that looks. So I'm going to switch it back. But maybe it's useful to know that the ordering in which things are appended determines what goes on top of the other thing. The last thing that gets appended appears on top. This is the Z ordering. All right, we have created an area chart of world population. What I'd like you to do is fork either this or the line chart example and change the data to create a line chart or an area chart. Good luck. That's all for making line and area charts with D3 and SVG. Thanks for watching. Take care.